Hi, Sanbonan. Hello.
Yes, Corner.
Yes, how are you?
We're fine.
Hey, right. Thanks for joining this class, right? Announcement after I finished. Can you just remind me what we did last time on Laplace? I think if I recall very well, I stopped when we were looking at how to use Laplace transform tables. Am I right? Just check. How to use Laplace transform tables. Am I right? Now let us continue then, but you will tell me if I repeat something that we have done. Okay. Right. Last time, let us move on. Did I say something about this? Huh? Unit?
No.
Step function. Did I talk about that?
No.
No, okay, right. That is our next lesson. Remember, to find the Laplace transform, we use the table that is always there in our guide. In the test or in the exam, I'll always provide you with the table of Laplace transform, yes. Now let us have a look at what is called a Heaviside unit step function. Heaviside was a student of Laplace, if I can just give you a background. Or he was just a friend to Laplace. When Laplace introduced the concept Laplace transform, Heaviside was also interested, but his interest was then on the functions that opens on and switches off. So when this function switches on and off, we all of a sudden think of an electrical function, of an electrical circuit, sorry. You can switch it off, you can switch it on. So Heaviside was interested on such function. We say such functions are discontinuous because when you switch an electric circuit off, the system is discontinuous in the sense that there's no power, there's no current, and you can also switch it on. So it's discontinuous at some time interval, and at some time interval again, you can make it on. So Heaviside was interested in studying the concept that was brought forward by his friend or his colleague by the name of Laplace. Now we look at his theory, his background. So Heaviside seems to be more strong than Laplace, but yet they sing the same song, Laplace transform. But now Heaviside, he studied the concept of, he looked at the functions that were discontinuous and as well as continuous at some time interval. Let us have a look at his theory, the background. No. Let us look at what a function that is Heaviside, defined as Heaviside. Definition, very important. We say, let f at t be some function. For t, of course, t is positive, right? Now, definition. Now we have this function, a function f at t. That does what? That maintains, you must tell me if I talked about this the other day, that maintains a zero value. That is, in other words, it remains at zero, a zero value for t less than zero. Now, in other words, think of a function. A function is always zero when t is less than naught. T is negative. And what is that now? What is that now? I don't need this. No. But I've never seen this thing here. I don't want to type here. Delete. Delete. I've never seen this, good people. I want to delete it. Anyone who knows how to delete this? Let me call my daughter to do this for me, please. Hafiz Salam. Now, technology. Delete. Oh, yes, it's deleted. Okay. A function f at t that maintains a zero value for t less than zero and and a unit. By unit, I mean just value 1, and a unit for t bigger or equal to 0. So in other words, we have a system or a function that behaves in this fashion. It is always 0 when t is less than naught. But when t is bigger or equal to 0, a function jumps up and it becomes 1. So such a function is called h of t. It's called a Heaviside unit. That unit stands for that jump, unit step, a Heaviside unit step function, denoted by what? H of t. So in other words, the function that maintains a zero value at t less than naught, but when t becomes naught and above naught, it jumps to 1, is called a Heaviside unit step function, denoted by h of t. Let us put that in mathematical terms. Mathematically, so h of t is equals to, it's 1. When is it 1? When t is bigger or equals to 0. Otherwise, it's not. When t is strictly less than 0. So there is my h of t. My h of t, it maintains a zero value. It maintains a zero value when t is less than 0. When t is less, or otherwise it's 1. When t is bigger or equal to 0. That is the mathematical interpretation of that definition. Please just mute there. Otherwise, graphically, there is someone who's disturbing there. Graphically, you can sketch the graph that is depicted by that. So there is the function. That is t, that is h of t. We say h of t, it's 0. It's 0. It sits there. It sits there. It's 0. When is that? Because here, this side here, t is less than 0. Otherwise, it's 1. When is that? When t is what? Is bigger or equal to 0. That is the mathematical interpretation of that. I mean, the graphical interpretation of that. So we are saying that t, the function f at t, h of t maintains 0. It's 0 when t is less than 0. Otherwise, it's 1. It jumps. Just look at this gap. It jumps to 1 when t is what? It's positive. So this is the Laplace, this is the Heaviside unit step function. Very powerful when we study the behavior of our electrical circuit. It becomes not when t is less than 0, but it jumps to 1. Just think of switching your circuit on and off. When it is 0, t is what? It's like it's dead. It's 0. But when it is 1, it becomes what? T, when t is bigger than, or when you open it, t becomes what? The graph jumps to 1. So can we find its Laplace? Its Laplace. Can we find the Laplace? Because there's a connection between Heaviside and Laplace. So the Laplace of h of t is given by definition of Laplace, 0 to infinity of h of t times a to the power minus s of t dt. But times what? 0, infinity, it's 0 dt. Why do we have this 0? This 0 is that. That 0 is that. Because h of t is defined in two terms, in two aspects. So one, it's not, there is not. That's the other one, it's 0 to infinity, it's 1 times what? Times a to the power minus s of t dt. Now, in other words, we are left with that part, but we know we don't integrate over that limit. When the limit is the infinite, we take the limit as b goes to infinity of naught to b a to the power minus s of t dt, and we've seen that it becomes what? 1 over s. So the Laplace of this h of t, which is the Heaviside unit step function, is given by that. In your notes, again, remember I said last time, each time we are busy with Laplace, you must have your Laplace transform table or the study guide with all tables there, with all the Laplace transform. That is on page 21. So on page 21, we have the Laplace of h of t. They did not indicate it there. They only gave us the next one. It's not given here. So the Laplace of h of t is nothing else but is equivalent to that of a constant, which is 1 over s. That is that. So the Heaviside unit step function is that function whereby it is always 0 when t is negative, less than 0. Otherwise, it jumps to 1 when t is bigger or equals to 1. So that function is called the h of t. H associated to the person who was investigating that by the name of Heaviside. So it's h of t. Mathematical interpretation or definition is h of t is 1 when t is bigger or equals to 0, or otherwise t is what? H of t is 0 when t is what? Is less than naught. Graphically, h of t stays at naught when t is less than 0. Otherwise, it jumps to what? It jumps not what it is doing now. Right, come back. Otherwise, it jumps to 1 unit when t becomes what? Positive. Its Laplace, it will be given, the Laplace of Heaviside unit step function is 1 over s, is similar to that of a constant. Next, definition. I call perhaps this one, it's 1.2. We have what is called a delayed Heaviside unit step. A delayed Heaviside unit step function. A delayed Heaviside unit step function. A delayed Heaviside unit step function is a function of this nature. Is h of t minus what? Minus a, which is defined as, it is always going to be equal to 1. When is that 1? When t is bigger or equal to a, otherwise is 0 when t is less than what? A. Remember, with the h of t, this h of t can be written as h of t minus 0. That is why when I defined it, I said it's 1 when t is bigger or equal to 0. That 0 is that 0 which is sitting there, just that I did not write it. And or otherwise is equal to 0 when t is less than 0, the same 0 that is there. Okay, now I am saying now a delayed Heaviside unit step function is h of t minus a is equal to 1. When is that? When t is bigger or equal to 0, or will be 0, the same definition as above. So it maintains a 0 value when t is less than a. Otherwise, it jumps to 1. When is that? When t is bigger or equal to a. Now, just think of this a here. Oh, perhaps I'll talk about it. Graphically, the graphical representation of that, or mathematically, oh yes, this is mathematical part of it. Then graphically, what about the graph of that? That is t here. That is h of t, perhaps h of t minus a. So it says the system is a little bit delayed now. There is my t here, t equals to a there. So the system is not, perhaps let me use a red pen here. The system is what? It's 0. It's 0. I don't want to pick up a ruler there. The system is 0 up to that point. The system is not. You can see here, it is not at naught here. It is not here, but it has been shifted by a units along t. So now the process is delayed now. That one is 0, but it becomes what? It becomes 1. There is my 1 there. It becomes 1. It becomes 1. When what? When t is what? When t is what? When t is bigger than a, is bigger or equal to. So in actual fact, we are saying exactly the same thing, just that this one here is a little bit delayed by a units to the right. So in other words, remember, t minus a is as if this function is pushed, has shifted a units along the t axis. The function has shifted a units along the t function, along the t axis. So this is called a delayed Heaviside unit step function. Graphically, can we find its Laplace? Its Laplace. Its Laplace. Its Laplace. Laplace of h of t minus a. It is also given in your study notes. That will be on page 21, number 25. Its Laplace h of t minus a is given by a to the power minus a of s over what? Over s. We can show it using definition, but we'll leave it out. Leave definition from first principles. I won't ask that. Perhaps if we're going to write full example, by full example, I mean a paper, then perhaps I was going to ask that question. Show or find the Laplace of h of t minus a from first principle, whereby you use definition. But in this case, I won't ask that question here because it will always be provided in the what? In the test. So the Laplace of h of t minus a is e to the power minus as over what? Over s. What role does this delayed unit step function has in general? The effect. We want to say the effect now of this delayed unit step function, Heaviside, to some other function, because it was not just what developed for no reason. There is a reason that lied ahead to this. There was a reason for this delayed unit step function. And what is that reason? The reason is as follows. The effect. We want to see the effect. The effect. 1.3 say the effect of what? Of h of t minus a on other functions. What role does this delayed Heaviside unit step function have on what? On any other function? Let us assume this function. That I'll take a simple function. Let f at t squared be my function, be a function. What type of a function is this? It's a parabola that opens upwards, am I right? That turns on the t, at the origin. Let us sketch it. Sketch it. There is the function. There is the function. Turns there, turns there. That's y there. The name of the function is y is what is f at t equals what? Equal to t squared. We can sketch that, right? Now I want to shift, I will shift this function here by the same amount or by something similar to that. I will shift this function by something similar to that. Now, I will say, suppose f at t is shifted by what? By 2, say, I'm just picking 2. I can pick A, but I decided to pick 2. I can pick 3. I can pick B. Is shifted by 2 units to the right of t, to the right of t. That is, in other words, my f at t, where there is t, I'll put t minus 2. Remember, when you move something to the right, and it has shifted 2 units. In other words, t minus 2 is t. So that will be what? T minus 2. In other words, this t now is replaced by t minus 2 all squared. Can I sketch that? Yes, I can sketch that. So the graph, this graph here, this one has moved 2 units to the right. So that's t here. That's f at t minus 2. That's that. So in other words, that graph now, it will be this graph. That graph. I hope you'll recall that. It will be that graph. There is my t here now equals to 2 here. There is my 2. So now my axis of symmetry is that. Yet my axis here of symmetry here was the y-axis, my axis of symmetry. But yet here my axis of symmetry here is now t equals to 2. Now, why am I doing that? Now, I want to combine this f at t minus 2 by a Heaviside unit step function that has shifted 2 units to the right. Now, I will say, suppose we combine f at t minus 2, the one on top here, with what? With the Heaviside that has delayed by the same amount as f. Now, suppose I combine that. In other words, I have f at t minus 2 and h of t minus 2. Does it make sense? Yes. Let us recall what we have said so far. By definition, h of t minus 2 means what? The system is 1. When what? When t is bigger or equal to 2. Remember, I had a here. It was bigger or equal to a. Now I have got 2. Otherwise, it's 0. when t is less than not. I mean, sorry, when t is less than what? When t is less than 2. So in other words, if I combine this parabola here, which has shifted by 2 units along t, and the same Heaviside unit step function, which has shifted by the same amount as this function. But I must recall the definition of HF. This is going to be 0. This is going to be 0. This is going to be 0. In other words, definition here will be, this is going to be 1 times f at t minus 2. When is that? When t is bigger or equal to 2. Otherwise, it's going to be 0. When is that? When t is less than what? 2. Where do I get this one? This one is for the definition of h of t minus 1. Because I've said h of t minus 1 is going to be 1. It's 1 times that. When do we have that? When t is bigger or equal to 2. Otherwise, now, ngihlanganisa lezi zinto zoyi-2 now. I've got f at t minus 2, which I said is this function, together with Heaviside that has delayed by the same amount as the original, as the first one, h of t minus 2. But Nasengiti, by the way, what is the definition of h of t minus 2? Definition of h of t minus 2 is what? It's 1. When is it 1? When t is bigger or equal to 2. Otherwise, it is 0. When is that? When t is less than 2. Okay, this whole thing will be 1. This one comes from that definition of this h of t. So it's 1 times f at t minus 2. You know 1 times what? T squared, t minus 2 all squared, when t is bigger or equal to 2. Or otherwise, this thing here is 0. This is 0. When what? When t is less than 0. If I were to sketch that, if I were to sketch this function here, I would say, okay, remember my f at t minus 2 is what? It's t minus 2 what? All squared. In other words, la, or perhaps let me squeeze it here. This can be rewritten as what? As 1 times what? T minus 2. If I replace that f at t minus 2 all squared when t is bigger or equal to 2. Otherwise, everything is 0 when t is less than 2. I want to sketch this graph here. This graph here, I want to draw a neat one. That is that. That is t. That is, of course, my y-axis there. What does this whole thing tell us? Right, let us try and sketch. Now, under normal circumstances, good people, this graph here, this one, t minus 2, is this graph. Is this graph. Are you with me? If this graph is all by itself, if this graph is all by itself, I'm supposed to get this graph. But now in this case, this graph here is not by itself. It is with this big h of t minus 2. Yes, are you with me there? Yes. Yes. Ngiyabona ukuthi le graph le nansi ukuba ibiyodwa ibizobe nje. Fine. There's nothing wrong with that. But now sengiyilumbanise no h of t minus 2. I said those two, let me combine those two. Combine them. Oh, by the way, what is the definition of h of t minus 2? That it is 1. If I go back, when t is bigger or equal to 2. So this one comes from the definition. So in other words, I've got f at t minus 2, which is that. Or otherwise, it's 0. Now, let me try and sketch that. In other words, if things were normal, if I were to sketch this graph only, I was going to get this graph. Yes, this is the same graph that I was going to get. Again, so this is that if things were normal. I'm using a dotted line here. But now, I've got this h of t minus 2, which says when h of t minus 2 are going to be available, or when h of t minus 2, you are going to appear, there is my t here, at this point here. There is my t equals to 2. So in other words, this part, this dotted part is not going to be seen of this curve. Mind you, this curve is h of t minus 2 equal to t minus 2 all squared. So this dotted part of f at t minus 2 is not going to be visible because from below, before t is equal to 2, is when my t is less than 2. Woman. Before I reach the turning point here, yes, Nyabona at t equal to 2 is when the graph, this graph will appear. Otherwise, this dotted line is where you are not going to see this because everything here is what? Is 0. Sorry, is 0. Is 0. Is 0. Is 0. This is 0. Is 0, which is that. So this is not going to be seen. This part is not going to be seen. We'll only see it when t is bigger or equals to 2. Yes, there is 2 there. Continuation of the graph. So what h of t minus 2 does on what? On f at t minus 2. So this h of t minus 2, according to the definition, does what? Suppresses. Suppresses f at t minus 2 when what? When t is less than 2. In other words, asiyiboni igraph ka f at t minus 2. Ngisho lokho ngesizulu. Ngamanye amazwi ngithi le graph ka f at t minus 2 ayibonakali ngesikhathi eyubani less than 2. Nangu use less than 2 la. Yabona ukuthi ngamanye amazwi lo uqinela lo ngoba awuzuvela wena ngalesikhathi kusekhona mina. Ubani igama lalo mina la u-h of t minus 2. Usenjani uthi wami? Use less than 2. Anoma ngezwakala yini? Angithi. Uthi wena mfana sihlala phansi, useyingane, uzovela nini na? Once I reach 2, nangiya u2 wami, t equal to 2. Then when a graph usungavela ke ngoba mina ngibe sengidelile ukuyibonakalisa kubantu. Anoma ngezwakala yini? Usho uthi lona lo uMartinus lo big H uthi wena uqinela lengane lencane small a uthi awuzuvela wena graph, awuveli because ngalesikhathi mina ngiyu-not is when t is less than 2. T is less than 2 from here shona ezansi angithi. So wena awuveli awubonakala. Ngiyothi mina sengigile ngaqeda enkundleni bese ngikudedela ke wena ukuba uvele. Uzokuveza nini na when t is at 2 or above that. Akithi ngiyambona ukuthi u-big H of t akasekho manje la, sekuvela lona lo esesinile enkundleni wadela sethi hayi ke mfana ngoba sengidelile ke nawe usungavela ke baba. So in English we say h of t minus 2 does what? Cindezela, suppresses f at t minus 2 at what time? When t is less than 2. But f at t minus 2 appears. Aveleke naye engasekho lutho esithebeni esethatha amaqashana amancane usewaqedile lo seyathatha usewathatha nini na when t is bigger equal to 2. Anoma kezwakala yini? Question. That is the role that is played by h of t on what? On small h of t minus 2. So it suppresses until such time that the function appears. Can we find its Laplace? Its Laplace again is also given in our table. Laplace of f at t minus a, I'm being general now, times h of t minus a is given by, that will be number, in our table there, in our study guide, that is number 26. It is a to the power minus as times the Laplace of f at t. This is very important, good people. So what does it tell us then? This simply tells us that to find the Laplace of f at t minus a times h of t minus a, we need to work out f at t as, we need to work out f at t as we will be given, but not always, in some cases, what? F at t minus a, as it is the case here. There is f at t minus a. But what we are, the final answer here, if we are asked to find the Laplace, we must work out what is f at t from f at t minus a. Then from here onwards, I'll play around with examples. So we need to find f at t from what? F at t minus a. That is all what it says. Following example. Examples. I'll pick just the example that is there. Find the Laplace that is there in your notes of t plus 1 times h of t minus 3. Now, let us start. How do we find that solution? So, what we are given here, this is my f at t. My f at t is what? My f at t, we are guided by that. T minus 3 is what? It's t plus 1. We are guided by that. This one will always guide us. So in other words, so we need to find f at t. Why finding f at t? Because we are asked here to find the Laplace of this function, which is given by that. And you can see my answer there is this times the Laplace of f at t, not the Laplace of that. So that is why we need to find f at t. Next. Now, therefore, in other words, in order to undo this t minus 3, in order to get rid of this minus 3, I can say t minus 3 plus 3, or t plus 3 minus 3. I'll always get t, so as to get f at t. See? So t, I can replace this t by minus 3 and add 3, so that I get t. Or t plus 3 minus 3, I will also get t. I can do it in different, but I will tell you now what to do, which will always be effect. In other words, this t minus 3 here, we must do what is called order preserving. We will preserve the order at which it is written. It is written here as t minus 3. In other words, we will say, therefore, f at, there is the t. So this t, instead of using t minus 3, I will say t plus 3, so that this minus 3 is always preserved as minus 3 there. So t, I will put t plus 3 minus 3, because my big H is minus 3 is equals to. Then what I've done on the left-hand side, I must also do on the right-hand side. There is t there. Where there was t, I put what? T plus 3 plus what? Plus 1. That is what? Is t plus what? Plus 4. That becomes, if you simplify the left-hand side, therefore f at t now because minus 3, positive 3 and minus 3 is that. So it's t plus what? Plus 4. Hence, what is the that I'm asked to find? The Laplace of t plus 1 times h of t minus 3 is equals to. Use that formula there. That formula there is going to be a to the power of a1 is this a, will always be negative. No, I'm not taking the negative. I'm just taking a as it is. So it's minus what? 3s as it is given there times the Laplace of f at t. Do I know f at t now? Yes, my f at t now is t plus 4. That gives us a to the power minus 3s bracket. Do I know the Laplace of t? Yes. From my table, is going to be what? Laplace of t is 1 over s squared plus. Do I know the Laplace of 4 is a constant? Yes, is 1 over s. And this is your answer. Okay, next one. I know perhaps you might be confused. Let me have a look at the next example. Next example is, it's again in your notes. It's again in your notes. Right, in other words, find, yes.
So the panel, Laplace, it's 1 over s, the panel move 4 over s.
But, oh, sorry. Constant was 4, yes. So, thanks. Yeah. Thank you. Now, next, find the Laplace of what? Of t squared plus 3 times h of t minus what? Minus 2. If f at t minus 2 is what? Is t squared plus what? Plus 3. In other words, that which is given there. Right? Now, remember, combination of that, we know it's Laplace. It's Laplace. It means we must find f at t. Can we find f at t here? Yes. F at t, sorry. F at t, this was supposed to be 3 here. Oh, yes, 2. F at t here. Yes, f at t here. So we need to find f at t. So my f at t will replace that minus 2. Do you see this minus 2? I'm going to preserve the order as to how it is written. So t is what? It's t plus 2 minus 2. Look how I write it. So I preserve this minus 2 because that is how it is written. So in other words, where there is t, I put what? T plus 2 is equals to. On the left, on the right again, there is t squared. Where is t? I put what? T plus 2. So it's t plus 2, but this t now it's squared plus what? Plus 3. That gives me what? That gives me, if I work this thing out, f at t is what? Is t squared plus what? Plus 4t, 4t plus 4 plus 3 plus what? Plus 7. So that is f at t. So my f at t is that. My f at t is that. Now, can I work that thing out? The moment I have f at t, I can find the Laplace of that. Therefore, Laplace of what? Of t squared plus 3 times h of t minus 2 is equals to, formula that is a to the power, what is my a? My a is 2, is a to the power 2s times the Laplace of f at t. What is f at t? It's t squared 4t plus what? Plus 7, which becomes a to the power minus 2s into. I know the Laplace of t squared, you take your table there, is going to be 2 factorial over what? Over s cubed, don't forget, plus Laplace of 40 is 4 over s squared, check your table, Laplace of a constant, 7 over s. That becomes a to the power minus 2s into 2 factorial. It's 2 over s cubed plus what? 4 over s squared plus what? 7 over s. This is your answer. That is your answer. Let's try 1 or 2 more. Right, Laplace of 2t minus 3 times h of t minus 1. For us to be able to work it out, we must first find f at t. Mind you, f at t here, if f at t minus 1, I'm guided by that, is equals to what? Is 2t minus. Now, I must find f at t. So my f at t will be, there is t there, order preserving. I must preserve order. I can undo that minus 1 by adding 1. So t, I'll say t plus 1 minus 1 is equals to 2 into t, there is t. Now also ubani, so t plus what? Plus 1 minus 3. That gives us what? 2t plus 2 minus 3 is what? Is 2t minus 1. Is 2t minus 1. Oh, that is my f at t. Therefore, my f at t is what? Is 2t minus 1. Can I find the Laplace then? Therefore, hence, the Laplace of 2t minus 3 times h of t minus 1 is equal to, according to the formula, it's a to the power. Now, there is the a I'm talking about. It's positive 1, so it's minus 1s. So it's minus s times the Laplace of what? Of 2t minus 1. And I find that it's easy, a to the power minus s. What is that? Laplace of 2t, 2 over what? Over s squared. Laplace of 1, it's 1. That is. So far, so good. Nisekhona noma niyadlala belihlezi khona manje.
Khona.
Hey.
Khona mina.
Sure. Right. Next. Laplace of sine 2 into t minus 3 times h of t minus 3. From here, find f at t. You can see that our f at t minus 3, this guides us, is what? Is sine 2 into t minus 3. Out of this, we must find f at t. Therefore, f at, there is t. So it's t plus 3 minus 3 is equals to sine 2. There comes in t, which is now t plus 3, what? Minus 3. That gives me, this whole thing gives me what? Sine 2t. That is f at t is what? Sine what? 2t. Can I find the Laplace then? Then hence, the Laplace of sine 2t minus 3, h of t minus 3 is equals to, use the formula, it's a to the power minus, there is 3, is 3s times the Laplace of f at t, if you like, which is a minus 3s Laplace of f at t, which is now sine 2t. We know the Laplace of sine 2t, yes, tables, a minus 3s. Laplace of sine 2t is what? It's 2 over s squared plus what? Plus 4, sorry, plus 4. And this is your answer. So far, so good?
No, sir.
Yes? Usale good deal?
Ngisale lapha ku S squared plus 4.
Yes. What is the Laplace of 2t? Of sine 2t? Check your table. Check your table. Do we have a study guide with you?
No.
Hayi indaba ilapho. Laplace of sine t sathi ubani i1 over s squared plus 1. Laplace of sine at iubani a over s squared plus a squared. So the Laplace of sine 3t is going to be what? 3 over s squared plus 9. So the Laplace of 2t, that's a, it's 2 over s squared, square a plus 4. Check your table, please. That is that, good people. That is that. So the role played by the Heaviside, that is delayed, we know what happens, and we know the combination. We can find the Laplace of the combination of a function as well as that of a delayed unit step function. Can I move on? Next.
Sorry, sir. Sorry.
Yes.
Mina ngiyayibona le delayed. Yabo yokuqala idedile yokuqala. Ngiyayibona le delayed. Khona lokuqale ngayo eqaleni.
Example.
Hayi example. Khona lokuqale ngayo eqaleni.
Heaviside.
Yes, lokuqale ngayo nje phezulu.
Yes.
Yeah, idedile. I understand. Ngiyayibona.
No, it's the definition. You understand the definition. Determine a Heaviside unit step function. Ile function 80 EU0. If value EU0 when t is what? Is less than, when t is less than naught. Otherwise, it is what? It is a unit. It is 1. When is it 1? When t is bigger or equal to 12. Ile definition yakho. Phela. Base ngithi ayibeka mathematically, ayibhala graphically, and ngathola its Laplace. Its Laplace is there in our table. Ukuze ngize kulena ngoba ngifuna ukintroduce le.
Okay.
Yayibona leyo.
Angiyabona sir.
Chap. So that is the story. Now, what is the aim of studying Laplace transform, good people? And so many things can be said about that. But what is our aim here? Why are we studying Laplace transform? Remember what I said the first day in class. I said we study Laplace transform so that we solve differential equation using Laplace transform. All what we are picking up now are nitty-gritty things, but our aim behind it, we want to solve differential equations. Fortunately, you are lucky, good people, because you are not writing an exam whereby I'll sit down and set a paper. When I set the paper, I'll usually include the plumbing delayed unit step function. But because of COVID, you are lucky. Because when you solve differential equation with h of t minus a, it becomes a problem. Because I will ask you to sketch a graph and indicate what you'll be saying, etc., etc. It becomes very, very, very tedious and awkward. But I won't go up to that level at this point in time. What is it that we need to know now? We are left with just one aspect, which I will do right now, then thereafter, we'll solve differential equations. Next section is a section on what is called the inverse Laplace transform. Good people, we have seen that when we are asked to find the Laplace transform of a function, Laplace function f at t, we get blah, 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 f at s. Yes, Laplace of a function, be it what it may, but the answer will end up with an s function in terms of s. Can we reverse the process? Can we reverse the process? Meaning, we are from Laplace function in terms of s. can we be given f at s and then be asked to find its what? Its function, f at t? Yes, we can do that by doing what is called the inverse Laplace. So if we are asked to find the inverse Laplace, it means the function is already in terms of f at s. Then we must find the original function, f at t. So this is called the inverse Laplace. If I give you 2, what is the inverse of 2? Inverse of 2 is what? It's 1 over 2, which is the same as what? 2 to the power minus 1. Right? So inverse Laplace, e.g., what function whose Laplace is 1 over s? That is the question. What is the function whose Laplace is 1 over s? It's a constant. In this case, is what? It's 1. Hang it, using table. In other words, we are moving forward now, we are coming backwards, and then we obtain the function f at t. What function? Inverse, whose Laplace is what? Is s over s squared plus a squared. What function is this? Check your table. What function whose Laplace is s over s squared plus a squared? What function is that?
Sine.
Sine. No, there's s on top. No. Check.
It's cos.
Cos what? It's cos 80, yes. Huh? What function? Inverse. Whose Laplace is what? Is 2 over s squared plus 4. What function is that? Sine. Yes, it's sine 2t, isn't it? Yes. What function is whose Laplace is what? Well, let me say is a, sorry, it's 1 over s minus 2. What function is that? What function is that?
E to the power pt.
E to the power.
A to the power minus 2t. Sorry, plus 2t. And it?
Yes.
Minus plus there. What function whose Laplace is 1 over s plus 3? That function is e to the power minus 3t. Am I right?
Yes.
But now, izinto ngezihlale ziwuthize ndipholo njengalo. Ake sibheke la. What function? Yes, perhaps this one is still easy. What function is what? Is s minus 3 all over s minus 3 plus what? Plus 9. What function is this? Whose Laplace is given by that. What does s minus 3 indicate? What is s minus 2? It means a shift. Again,
Yes.
it's a shift. It means there is this exponential. So it's e to the power negative 3, so 3t. Unjani?
Sure.
Because there was s there, that's a cos function. Cos,
Cos.
this is cube. Cos what?
3.
3t. Yes, perfect. Yes. What function is whose Laplace is what? S plus 4 over s plus 4 plus what? Plus 16. What function is that? Again, e to the power minus 40. Again, yes, times s and s there. That's a cos function. What? 40. What function given by this Laplace here? It is 5 over s minus 1 all squared plus 25. What function is this?
It is
It is e.
minus
It is e to the power. It is e to the power.
Oh, -1.
1 of t. So to the power t, and it.
Yes.
Yes.
And then
Times what?
Cos.
cos t.
When is it
Times
cos?
sine.
Sine, yes. Sine what?
5t.
5t, perfect. Yes. What function given by this Laplace? 1 over s plus 2 plus what? Plus 1. What function is that? Of course,
It is
sorry, squared. It's going to be what? E to the power?
minus 2t.
2
Minus 2t. Yes,
And
sine
then
what?
it is sine
t.
Sine t. Sine t, is it?
Yes.
Yes.
Because my A is there. So you can say that you can reverse the process. Go take a okay? Can be asked to find this Laplace here. You can't be asked to find this Laplace in your notes. Well, perhaps this one is easy. Laplace of 4 over what? Inverse Laplace of 4 over s to the power 6. That is on page 24 in your notes. This can be written as 4 inverse Laplace 1 over what? S to the power 6.
Over 1 over.
Again. Now, if you look at s to the power 6, remember, this s to the power 6, niyayikhumbula formulate n factorial over what? S to the power n plus 1. Niyakhumbula?
Plus 1 is.
Yes. Kushuthi, this 6 here beku 5 plus 1. Are you with me, good people?
Yes.
Yes. Okushuthi la u1 lo kufanele kube uba u4 inverse plus kube u5, but what? Factorial. Again.
Yes.
Over what?
Yes.
Over s to the power 5 plus 1. But now I've multiplied by 5 factorial. I must divide by 5 factorial. So that will give us 4 over 5 factorial. What is that? It's t to the power 5. Again, because this is the Laplace of t to the power n. So what is 5 factorial, good people?
120.
120.
120.
Yes, t to the power 5. And this is your answer. Okay. Well, that was relatively easy. What about this one? What about this one? That is number 7. Inverse Laplace of s minus 1 over s squared minus 6s plus what? Plus 25. We look at that one now. Nyabona ukuthi lesa manje akuselula ukuthi to spot it. It's not easy to check our Laplace transform table standard and have the answer. Nyabona ukuthi akusalungile lo. While the others were very simple to work out, but that one is not that simple. It means we need to do something first. We are asked to find the function whereby that inverse Laplace, that function, that Laplace comes from. Now, how are we going to work it out? If you look at all my formulae having s squared, a squared. From here, we complete the square. We complete the square. This is quadratic, complete the square. So when you complete the square there, that is s squared minus 6s plus 25 to give us, complete the square. The coefficient of s squared has to be 1, which is the case here. Half of that, so is s squared minus 6s plus half of minus 6 square that. That's what? 25 minus half of what? Of minus 6 all squared. That gives me s squared minus 6x plus what? That is minus 3 all squared plus 25 minus 3 all squared. So it will give me s squared minus 6s plus what? Plus 9 plus 25 minus 9, that is what, 16. If you look at the first three terms, la wire, that's a perfect square. That's a perfect square, which factor out as what? As s minus 3 all squared plus what? Plus 16. Yes, plus 16. Now, I then redefine that. Therefore, what I was given, inverse Laplace of s minus 1 over s squared minus 6x plus 25 is equals to inverse Laplace of what? Of s minus 1 over what? Over s minus 3 all squared plus 16. But up until here, this does not make any sense. This one, look at this one. S minus 1, S minus 3. This S shift, S must shift by the same amount. So S here has shifted by 3 units. Angit? This S must shift by 3 units. We'll check that. We'll what? We'll shift it by the same amount. So inverse Laplace of. So S must be S minus 3. But I must go back to minus 1. Find against minus 3 plus what? To give you minus 1 plus 2.
Plus 3.
All over S minus 3 all squared plus 16. That gives me. Then I split. When I split inverse Laplace of what? Of S minus 3, I've seen that, over S minus 3 all squared plus what? Plus 16, split, plus inverse Laplace of what? Of 2 over what? Over S minus 3 all squared plus what? Plus 16. That becomes, now I know that. What function is given by this Laplace? There's a shift. Ubani e to the power 3t. Angit? There was s here, so that's a cos function. Cos what? This is cos what? 40. Yeah. All right? Plus s regular. La is a shift. S minus 3. But now this is 16, which is 4 squared. So this is supposed to be 4. Am I right? So I compensate first. I multiply by 2 so that I get 4. Then I divide by half. I divide by 2 at the same time. So that will be what? 1 over 2. Then what? Shift is a sine function. A to the power what? 3t what? Sine 40. That is the function that was given. So far, so good. Right?
Yes,
Let's have a look at another one. Kuluma kakhulu, kuluma nami no?
Sir.
Iphinde lesibali.
Yes, Lange. After
Completing the square. Okay. Ngayithatha ngayibhala kule denominator as that ngoba sengiyazi ukuthi mangicomplete square ngineza lokho. Okay? Base ngizobheka la. Uyabona u-s minus akile izinto kufanele zifane. Uma ngishifte u-s by 3 units, nala kufanele ashifte by 3 units. But I can't change this one because this one gives me a guide what to do on that. So maku s minus 3, this is supposed to be s minus 3. That's it. I want to shift the top one by s minus 3, not s minus 3. Kodwa beku minus 1. From minus 3, what must I do so that I get minus 1? That s minus, so minus 3 plus 2 is minus 1. Agit?
Oh, yes.
That's a good. That's a good, okay. That's a as if I'm integrating. That's a split. I split entweni engiyazi. Le angiyazi le nansi ngayikhipha yodwa. Ngoba isi right isilungile. Ngasala nale. Nansi. Mase ngifika la, what function is this? Ngayithola ukuthi shift exponential 3t cos 40 is correct. But this one, isi right kodwa kuphelele ukuba right kwayo. U4 la o squared kuze kube u16. Fanele kube u4 la. But being no 2. and multiply with 2 so that I get 4, but divide with 2 so that I have got that. Which is okay.
Oh, say. Then ukuze sewukuthi kuyenzeka yini ukuthi i-denominator ibe neveli engaphezulu kwe-numerator.
Ibe neveli
njengoba yabo nje sela kade ku-1 no-3 kwenzeka ukuthi ku-shift ama-position kube u-3 no-1 kuyenzeka.
Yes, kuyenzeka nakhona. Yes. Kodwa thina sifocus le eno-s squared ukuthi iyona ekufanele kube ubani e-shifting. Maku s plus 1 kusibuyela kule phezulu siyoyimanipulate sithole s plus 1. It's s plus 1 minus or plus to go back to the original. Yayibona leyo nto. Mhlawumbe siwathola as time goes on. Find the inverse of the following. Fine. Yes, let's try number 13. Number 13. Find the inverse of 2s cubed plus 4s squared plus 32s plus what? 264 all over what here? S squared plus 16 into what? Into s squared plus 2s plus 10. Find that. Now, this one here is different. So here we'll make use of what is called use partial fractions. Use partial fractions. Use partial fractions. So you drop the inverse Laplace, you have only 2s cubed plus what? 4s squared plus 32s plus 264 all over what? S squared plus 16 into s squared 2s plus what? Plus 10. Partial fraction, remember the rules for partial fractions. So partial fractions, quadratic without factors is as plus b over s squared plus 16 plus, there are no factors here, cs plus d over what? Over s squared plus 2s plus what? Plus 10. Remember, that will be, that will be 2s cubed plus what? 4s squared plus 32s plus 264 is equal to as plus b into what? Into s squared 2s plus 10. I hope you recall that. cs plus d into what? Into s squared plus what? Plus 16. That gives us, multiply there, as cubed plus 2as squared plus 10as plus bs squared plus 2bs plus what? Plus 10b. Indicate to me if I miss some terms. cs cubed plus 16 cs plus ds squared plus what? 16d. You will recall you grouped all terms that are identical in terms of s cubed. So a plus c, they all have s cubed in common. Then the squared ones will be 2a plus b, they all have s squared, plus the s ones, it's 10a plus 2b plus 16c, they all have s. Then the fixed terms.
So sir,
Yes.
laphana the term layer s squared ukhohlo d.
S squared. We're here.
Plus d. La kuthi a plus b kumele kuthi plus d.
2a. Ile term noma la?
The term le abano s squared kumele kuthi a plus b plus d.
Kule terminal noma kule. Oh, la. Ima plus d. Yes. N plus D. Thank you. Right. Therefore, the fixed ones will be 10B plus what? 16D. Those are independent. They all give us that. And equate coefficients. We start with S cubed. S cubed terms. How many? 2 of those give us A plus C.
Sorry, sir.
Yes?
Nala ukhohlwe 16C. La ugcineni, 16C. Yeah.
16C.
Yeah.
Thank you. 16C.
16C. C.
Come Gablo 16C.
Now, that's it. 16C. Now,
No?
yeah, the last, now 3 ugcineni.
But to S now 16C la.
Oh.
Over S. Yabo?
Sabon.
So akekho lo siyavuma.
Yeah, siyavuma.
Sure, right. Then S squared terms. 4 is what? It is 2A plus B plus what? Plus D. And then S terms, 132 is equal to 10A plus 2B plus 16C. Equation 3. Then constant terms, Bani 264, Ubani 10B plus 16D. That is equation 4. Now. Right, what? Right. A is, first one is A plus C. If I were to take 1 and make N1 the subject of the formula and plug it here, I'll be bringing in C. I'll be bringing in C here. And if I take this one and plug it here, I'll be bringing B and C. Now, let us see. So, in 1, A is what? It's 2 minus C. Let's call that one is equation 5. Then spin the Zote. Now, if I put that one here, let me go to 3. This is Zote. In 3, in equation 3, I put A, I substitute by A. So I will get what? 32 is what? It's 10. There is A, which is 2 minus C, plus what? 2B plus 16C. That will give us 20 minus 10C plus 2B plus 16C. That gives us 20. That will be what? Right. Perhaps let me have it here. If I transpose that, 32 minus 20 is what? That is 12. That is 12 is equals to 2B. 16 minus 10 is what? It's minus, so it's plus 6C. Divide by 2, that will be 6 is what? It's B plus what? 3C. That is, or leave it there. What next? That is in terms of C. Then here there is no A, there is no, let us come here again to this one I was avoiding. T in what? In equation, what equation is that? Equation 2. We have 4 is equals to, it's 2, there is A, which is 2 minus C plus B plus D. It gives us 4 minus 2C plus B plus D, that is 4, 0, it's minus 2C plus B plus D, right? What more? And then what here? 2C is B plus D, right? Where does that take us to? What is this? Right. There is B there. I'll be bringing, if I were to take this B and substitute there, I'll be bringing in C and D. Any equation with C and D? Only. Are we still together?
So
Right? Yes.
Bese ngathatha ngani like equation. I think nganoma equation 2 yini no
Yes.
equation no equation 3 mase sibeka omunye ngaphezulu sibeka omunye angezansi mase sizama ukukhansela u-b noma sikhansela u-d because equation 1 no 3 I think abantu b no d bobabili
Abafanayo. Ama-coefficient afana sibhekene ama-coefficient abafanayo. Ubani equation 2 no equation 3 ama-coefficient afanayo. U-a lapha u10 u2 lapha u10 la kufana u2b la u-b ayikho ezokhanselana la ngaphandle mas-multiplier. Yeah, uyayibona leyo nto. We are doing exactly that now. Yes. Yiphi enye equation now? Our A is that, our B is that. If I make B here and plug it here, I'll be bringing what? C and D. Equation no C and D. Ayikho. Since I got equation yet, 2A, A is A plus C. I think we are correct. A and D. How come? How many unknowns? We've got 4 unknowns in 4 equations, is it? Yes, we've got D and 4 equations. Must come out. So that one and that one, the B plus D, B, D there. Okay, so sebenzisile equation 4, no? Let's try equation 4. In equation 4, we've got 264 is 10 being used by equation 4. Equation 4. I get it. No, I'm out there. This equation, let's spell the equation. If ngizofaka ubila, right? So I called this equation 5. Bese ngizothi from here, B is what? Is 6 minus 3C. So that is my equation 5. So B is 6 minus 3C. If I plug it there. And okay, gizela. Okay, fine. Bese ngithatha lo, ngiyayibona le equation by 6. Bese ngizothi ayicishe siyoyikhipha ke manje. Bese ngizothi put 5 in what? 6 your number 6 balance, right? So that we've got 2C is equals to B, which is 6 minus 3C plus D. So that one and that will be 5C is what? It's 6 plus what? Plus D. Where? D. I man. 6 minus 3C plus D. I wanted to go somewhere. Okay. Bloom, I wanted to go somewhere. 5C is that. Let us call that is equation 7. Spaghetti foot and equation. And then 5C is that. I go let's know 5C con. I go. That 2C. Then if I were to put C here, so no A no D. Con equation no A no D. I 2C and that. This one comes there. This one is this one. Yes, this one. Okay, what then why are we failing good people? So fagilu A la or bungek A la. B plus 3C. No. Yeah, well, met student. So like simultaneous equation, huh? Kuluman Badot, Kuluman.
Thanks.
Right lapha phezulu.
Ayibona le equation le eno
Like no
Enoba.
6 equal to B plus 3C.
Yes.
Like no 6 equal to B plus 3C.
Yes.
That would be subject to formula.
Nangu. Ngimenzile impela nangu.
Yes, sir. Then bese siya kule ASB lo yenzile ekhiphe u2C. Ekhiphe
2C
u2C equal to B
plus
plus D.
D. Ngenze lokho impela nansi. Nansi.
Bese senze the subject of the formula.
Senze bani?
D, sir.
D.
Yes.
Therefore here D is what? Is 5C minus what? Minus 6. That is 7, right? Let's say this was up.
This is weirdly equation.
Sorry. Which equation?
Yeah. Equation.
Le?
X is equal to 2A plus B plus D.
Le, oh, sengikhohle khona le. Oh yes, khona le, angithi? Yes. Ake senze into oyishoyo man. Yes. Mhlambe kuzokwenza umehluko. So sengizothi equation 2 in 2. Sengiyikhohliwe le. In 2, 4 is equals to what? 2A plus B plus D.
Yes,
2A.
2A is 9.
2A plus B plus D. Angithi? Ubani esinayo A isinayo angithi?
Yes, 2 minus C.
2 into 2 minus C. B is 9.
Yes, that's 9.
6 minus 3C. D is 9.
Yes, sir.
Yes. 5C minus 6. Thank you, Nganyam. Bese sikhohle le equation. Yabo sesino C wonke la throughout. Yes. Thanks. Then that will give us 4 minus 2C, 6 minus 3C, 5C minus 6. Perfect. Right. This and that would be 10. Minus 6, that will be what? That will be 4. Minus what? This and that, ubani, that and that. What pen you see? Yabo chapel. Logia, nalogia, nalogia. See, it disappears. Yabo leon. Senze kahle yini?
Sir,
A plus D. Yes.
Sengicela ukubuza.
Yes.
Lo affecting lo angithi kule formula le la bese 2C equal to B plus D. Equation 4.
Equation 4. 2C is B plus D. Yes.
Yes. Why singamenza khona D subject of the formula?
B. Ngimenzile nangu la. Nangu. Hayibo. Wait. Angimenzanga la. Right? La B ubani u2C minus D. Ayikho into njenge ngayibhala. Bese ngiya kuphi?
Now so much.
But uma ngifake yena le formula le.
Yes, sir. Shintsha laphayana uD kube uyena oyi-subject of the formula, then uB umbuyise ngale 2C.
D abe subject of the formula nangu. Usho lo?
No, sekuleya equation 4.
Equation 4.
Yes.
Equation 4 lana, equation 4. Equation
2C
4.
equal to B plus D.
Oh, guess what D? La.
Yes, because uB says 9.
Okay, so D is what? Is 2C minus B, right?
Yes, ususa 5C.
Bese ngiza kule equation 2. Angithi? Cancel yonke le yanto. With 4 is equal to 2A is 2 minus C. Angithi? B ubani? B uba. 6 minus 3C. I think we'll end up with the same thing. 6 minus 3C plus. Then D hilo. This, we are bringing in B, we are bringing in D then. Oh, okay, let's carry on. No, they are not going to cancel. We'll get 2C in there and that. 2C, we are bringing in B. 2C minus B. Yes, that will give us 4 minus 2C plus 6 minus 3C plus 2C minus B. Like terms, see our paid. That one, okay. That one and that one cancel. Sale no bani. No. Zobaba 10 minus what? Minus 3C minus B equal to 4. That is transpose minus 6. It's minus 3C minus B. So this is Ibona land. So this is 6 is what? It's B minus 3C. We're going back. That's, yeah, we are going back in circles. I'll check this problem. Good. Yes.
ukubuza ukuthi mina ku-right yini lapha kuma-equation wethu lawo esiwathole ekuqaleni.
Yes.
Mina ngaze sinkinga la ukuthi bafanele si-check-e ama-equation lawo esiwathole la ekuqaleni.
Okay, multiply in so I check it, right? What is what? What is AS times AS is AS cubed, né? AS times Z is 2AS squared, that's correct. Then 10A, 10AS, that's correct. Next, CS cubed. No, BS squared. Here, correct. Then 2BS, 2BS. Then 10B, 10B plus CS cubed, CS cubed. Plus 16S, 16CS, plus DS squared, plus 16D. Combine equation, this and that, S cubed. Next one, it's 2A plus B plus D, they all have S squared, plus 10A plus 2B plus 16C, they all have S. Then 10B plus 16D, yes. AC, that's 2, 4 is 2A plus B plus D, and 32 is 10A, 2B plus 16C. We are correct. I think the problem per se is not correct.
Sorry, sir.
Yes.
Sir, yabona khona lapha ekugcineni sir, u-B uphinde wawubuyisela kanti u-B sesinaye lapha ekugcineni ezana.
Okay, again get up. Right la.
Yeah, angane uyabona u-B lapha ukuthi sesinayo vele u-B uba no 6 minus 3C.
Yes. Le equation angithi. Konke lokho le equation phela iqhamuka la. Le calculation la, yonke le calculation. Inginikeza vele into enginayo.
Yeah.
Uyayibona yona?
Yeah, ngiyayibona.
Yeah. Hayi ngicela ukuma la ngisazokwenza isibheke kahle. Mhlambe khonto wrong esimisayo. Please. Let me just stop here. We'll carry on Monday, né? Monday, Tuesday. I will tell you.
Ngicela ukubuza
Yes.
lento ayishoyo lo mhlaqeda ukukhuluma usho laphayana ku-2C minus B, angithi u-B besinawo lapha la i-subject of the formula besimenzile.
2C equals to?
Angithi u-2C la sekwi-bracket laphayana ufake u-2C minus B, of which u-B sinaye lana.
U-B sinaye, ukephi lapho u-B?
6 minus 3C.
Yeah.
Yes, sir. I think kumele sifake yena lapha kumele sifake. Yes, sir.
La.
Yes.
No, we'll come back to the same thing again. We'll crash. We will crash. Lungile asufake lana kulo B. Ubani u-B? Sukelela. 6 is B minus 3C. Ngoba yonke leyo nto iqhamuka la ngithi. Lo B uthe ubani u-B manje? We will crash again. 6 is what? It's B. What is B? 6 minus 3C. Minus 3C. You see, 6 and 6 cancel. Okay, minus 3c minus that is minus 6c. Oh, c is 0. Huh?
Yebo.
I seem not to be happy there. C is 0. What is B? So 6 is B minus 2C. Therefore, 6 is what? It's what? It's B. C is 0. I'm not happy there. And then what is what? What is D? D is minus 6. D is minus 6. What is A? A was 2 minus C. A is 2.
Angenzeka kodwa sir.
Kungenzeka. Let us stop here. So siqala kahle Monday ne. Ake uqhubeka labo siyenzeka yini. Okay. Yes.
Okay, sicela ubuyele kusona isibalo phezulu ukuze mhlawumbe umuntu ezozama yena.
Yeah.
Manje masiningi kanje asibona.
Yes. Right.
Yeah, cela usibhala.
All right. Let's practice a car, okay? I think we might be missing out something here. Then I think Monday is on Bona face to face. Is that okay?
Yebo.
Yes, I think I'll see you face to face. I think with your scripts, but good people, I'm very much angry in as far as your script is concerned. Akopela isiZulu. And I'm very uncomfortable about that. But we'll discuss that on Tuesday. Yes. I'm going to penalize you severely. Maths 2 nina senior students akufanele nikopela. Kusho ukuthi no gesi engizosakhela wona uyobuqhuma kusho ama transform kwenzeka zonke lezi. Yabo leyo. Soba ne load shedding ingasekho. Please. More especially question 2. I mean question 3, operator D. That is where you copied a lot. But I'm done with it. I will see whether I give you scripts or I hold them back, then wait for some time so that I give you another test as a replacement. Thank you. Thank you. Naningezanga lutho.
Yes, wakhipha into
Akopela nonke. Sifa ngamvunye. Lalelani wenganza kwethu. Asivumeni abanye beni babekopela vumani lokho. Abanye cha. Ngiyakuvuma na ukuthi babekopela na.
Asazi.